Thank you, Pablo, and thank you everyone for joining. I think we are already more than 35 people on the room, and we expect to have more audience. Before we start, just a quick technical notes you can see here, just to invite you to participate in the chat. You can also introduce yourself and participate in the QA session that we will lead at the end of these presentations. So just a brief overview of this webinar. So as you know, we are two projects that join this initiative, and we were supported by the European Commission through the Booster program. And we also have here today in the audience our sister projects. Just for you to know, we are part of these SustaFuel clusters that are 10 projects, mainly with a similar focus and synergies. And we will start by showing the first dissemination material that was also created by our colleagues from the Booster program. So please stay here. We will share the video to open the webinar. And today in the agenda, it will be delivered by our two coordinators from ALFAFUELS and SUSTEPS. So we have also Dr. Kyriakos, who will be starting this session, and he is part of the advisory board of ALFAFUELS project. Dr. Harris from ALFAFUELS and Dr. Abdullah from SUSTEPS. So just to start, I will stop sharing to open the video, and I hope everyone can see it. Can you see the screen?
Yes.
Okay.
Industry and imagine a world where CO2 captured from industry and sunlight can be converted into sustainable aviation fuel. Well, it's closer than you expect. The ALFAFUELS and SUSTEPS projects are advancing innovative technologies in the field of sustainable aviation fuels. While SUSTEPS focuses on converting microalgae biomass through hydrothermal liquefaction into biocrude and on upgrading it into advanced biofuels, ALFAFUELS develops a biological and photochemical route, converting CO2 into isoprene using engineered cyanobacteria and then transforming it into jet fuel through solar-driven photochemical processes. To push the boundaries of biofuel innovation further, ALFAFUELS and SUSTEPS are now collaborating through the SustaFuels cluster, sharing a common vision, developing circular and complementary renewable fuel pathways next to Algisol, Cactus, Cockpit, Fuelgay, Icarus, Niagara, Sunfusion, and Suez Alga fuel projects. Besides building a community around sustainable biofuel innovation, SUSTEPS and ALFAFUELS are effectively unlocking renewable fuel pathways, circular and efficient. Discover how SAF technology reduces aviation's reliance on fossil fuels. Browse on ALFAFUELS and SUSTEPS websites for more.
So thank you very much. And now we will leave the floor to Dr. Kyriakos, please.
Thanks a lot. And I'm trying to share my screen. Do you see the screen?
We cannot see the presentation, Kyriakos. Open the presentation. Now we can see it.
Okay. So my name is Kyriakos Maniatis. I've been working for several years at the European Commission, Director General for Energy, always involved in energy from biomass and waste streams. And for the last 20 years, I've been working on advanced biofuels and sustainable aviation fuels. I will try to give let's say, my own perspective about the market overview for sustainable aviation fuels. Now, in principle, when you start with a new fuel, you need a kind of an ecosystem. And a successful ecosystem for advanced biofuels or SAF needs always to have, first of all, a stable long-term policy, reliable technologies in the market, viable value chain, because you don't need only the technology, you need the complete value chain from when you start from the resource, whether it's biomass or anything else, or CO2, how you take it to transform it to the plant, which makes the conversion. Of course, you need a very strong industry involvement and engagement and leadership, adequate and very strong financing, an operational market, and of course, social acceptance. And for those things to happen, they have to happen simultaneously at the same place at the same time. Now, we have to actually understand that the term ecosystem also recently started being used in the European legislation, while actually some other countries like India and China, it has been used for several years, for more than a decade, actually. And basically, to have an ecosystem developed, you need the strong initiative and leadership by the government, of course, in close collaboration with the industry and the academic and research community. Otherwise, it's never going to work. Now, as everybody knows, biofuels and sustainable aviation fuels is a global industry and, of course, a global market. And here you see more or less how this, let's say, the market's going to be moving. We see that, let's say, UCO might be going specifically from let's say, China and other countries to Europe, with main port in the Netherlands, Rotterdam. Excuse me. So the same with palm oil residues. And we see that other agricultural, let's say, residues like soybean oil are going to be going to the US and India and so on. So global market, global issues that they have to be addressed. This is the situation of the policy related to SAF. We see that, for example, countries that they are in blue, like here with the US, they have policy targets, they don't have a mandate, while we hear that the European Union and the UK, they have a mandate, actually a real target to be met. Other countries, which is very important, we see that China, India, and Brazil, they are developing a mandate. They have announced it, but it has not been put into legislation yet. And some other countries, like on the Far East, Japan, Thailand, Malaysia, and so on, they have again policy targets. And we see, let's say, countries like in Africa and also that more than others developing their policies, and they're trying to see what's the best way forward. So again, global issue, global market, but also global policies develop almost everywhere, I would say. Let's take a close look to the European legislation. You see there are several, I would say, actions, legislation, directives that more or less they are involved. They are taking care of transport and energy. And however, it looks nice, it looks artistic. The question is the real strategic thinking behind it, or this labyrinth of legislation and policy? And of course, are there incentives or barriers for investors? Actually, they're both. They're barriers, but they're also incentives. So it's a rather complex situation. Europe is a complex market based on the legislation we have. I'll continue to the next one. And of course, let me go through them very quickly. There is the complexity of legislation. Often there's contradictions within the European legislation. The legislation changes almost regularly. Every 2 or 3 years, there's a new RED. Now we're in RED 3. God knows, we might go to RED 4 in a few years from now. And there is another major problem. The industry can always reach the Commission, and the academic community can always reach the Commission and discuss with them. But the Commission, it's my own experience while I was there, we hear, but we don't listen what is the message coming from I would say, from the technology developers and the academic people. And the best case, for example, is the E20, E25, the blend to petrol. The industry was pushing for that. The last moment, the Commission didn't go through with it. So that's why we saw some of the big cases like Clarion being more or less abandoned. Then we have Annex 9. It's a very difficult thing. Annex 9, basically, you don't have a list of features that can be used or not. There are different other ways of doing it. Perhaps I would say the US has done a better job on this than we have. Then the restriction of the use of food-based fuels. I know this is more or less kind of a emotional issue. We don't have lack of food. The point is that sometimes the food doesn't reach the hungry people. but we don't have. We produce more food than we need, and we waste a lot of food. And of course, then the other issue is, why do we have a minimum 60% greenhouse gas reduction? Why not 50? If I have a problem, I can reduce by half my problem. Why I'm not doing it? And by putting 60 or even 70, you reduce the number of, let's say, resources we can use. So what is typical in the EU legislation is that we're trying to go for the best future solution rather than using what is good and available for the moment. We're always Europe tries to be on the ethical leadership. This is a good example. This is let's say, how sustainable aviation fuels was used in the States. They were produced in 2022. We see that basically the majority of the production was based on food-based fuels, and only a small fraction was based on animal fats and UCO. So now, how can the European industry producing sustainable aviation fuels compete with the US based? And the same point is that Europe cannot import these fuels coming out from the US because they are food-based. And this is one of the limitations we have, let's say, in the market. Now let's go to consider a little bit more about the mandates. We see here in the bottom, what you see, the gray is the mandate about biofuels, and the dotted is the mandate about the SAF. We see that more or less it was possible to meet the mandate on fuels, on biofuels for SAF, but after Shell announced that they would shut down completely the facility they were building in Rotterdam, it's hardly unlikely that this mandate is going to be met. And of course, we see what are the announced supply for SAF, and of course, we see here what was the mandate. If we take a global picture, we see the same thing. We see that, of course, HEFA is the only reliable fuel for the moment. We see that the let's say SAF, which is, let's say, Fischer-Tropsch and alcohol jet, has to make a significant contribution, but these technologies are still in the development stage, where there is one or two examples in commercialization, but still they haven't really penetrated that. And again, we see the huge amount that has to come from the SAF and the technology you're developing about carbon dioxide. However, this is the target that we have to reach, and we see there's still a gap in all these, let's say, targets, what the technology can provide, but what the aviation sector and the countries they would like to get. The next one is the pricing of SAF. Of course, everything has to be compared to the conventional kerosene price, which is about, let's say, 800, a little bit more than 800 euros per ton. And here we see the estimates. This study was done by EASA. We see here the estimated cost of the CO₂ fuels. We see here the costs about the hydrogen-based fuels, and we see here the fuels. Let's say, like here is HEFA, the ones produced from biofuels. So very strong, I would say, price difference, and very expensive. Anything except kerosene, conventional kerosene, is rather expensive, and it will be very difficult to compete for the industry. Now let's move to an important area in the market. This is the exports of UCO from China. And at the same time, on the right-hand side, we see what China is building. The blue dots, they are, let's say, under constructions. The green are in operations. There are 2 facilities in operation, and of course, they're planning even more. And of course, China is going to play a major role in this market. Why? Because they're exporting a lot of UCO. All the commercial facilities in Europe producing SAF from the oil companies like Eni and others, and have their best basically on UCO coming from China. Now, China is planning to have a SAF mandate. If that will take place, of course, a lot of the SAF will be used locally, and a lot of the UCO will stop being exported because it has to be used locally to, in a way, to feed all these new facilities being planned. At the same time, the SAF produced in the US, the majority of it is based on food-based feedstocks. So the question is how Europe is going to import SAF based on our own legislation, for example, excluding food-based fuels. And keep in mind that both China and India, they're planning to build within the next few years a huge number of airports. I make a search in Europe, no new airport, maybe in a small island, in a small Greek island, they might build one. But globally, a major airport with international flights, there is none. While we see what's going on in China. And of course, all these airports, they need planes. All these planes, they will need fuels, and of course, within this fuel, they would need more SAF. And with that, I will give you some of my personal observations. We have in Europe a very complex and sustainable legislation. And really we see that there is some backstepping. And the best example is what has been discussed now and expected to take place. The internal combustion engines, the deadline by when they can be produced is going to be postponed rather than having by 2035. The red raises actually obstacles to the industry and limits its competitiveness. We have very good technology. We have companies like Axens, we have companies like Chempolis, but however, these ones, they are building their facilities not in Europe, but elsewhere. They're building in India, they're building in the US. And also we see that big oil went back they completely abandoned the contribution or the plans they had about what is building sustainable aviation fuels facilities and so on. So this is an area. And the question is how we're going to meet our targets in sustainable aviation fuels. A lot of progress has been achieved in Europe. Your projects, you know them very well. There's a lot of innovation, but the point is that they are not going to be commercial before 2035. It takes a lot of time, and actually I had the slide, but because of the time I deleted it, there is no technology that was able to reach the market within 5 years. And this is the problem that the Commission in Brussels, they think, oh, if we make a mandate by 2030, the technology will be there. No, it takes 10 to 15 years to bring technology from the innovation stage in the lab to the market. And then if you build a new plant, it takes you 3 years to commission it, blending, all this kind of thing. So there's going to be a gap in what we expect and what we're going to get. If China is going to implement its own mandate, then there are going to be really problems in the global market, and of course Europe will suffer. And of course, there are real opportunities in what you are doing about, let's say, CO2 and hydrogen-based fuels. And this kind of application technologies, they need much more financing and work. And let's say, much more efforts have to be done. And with that, I will thank you for your attention. And later on, if there are any questions, I'll be happy to answer. I'll try not to stop sharing.
Thank you very much, Dr. Kyriakos. Now we will invite Dr. Harris, please, from ALFAFUELS project. He will present the conversion of carbon dioxide streams to sustainable aviation fuels, and yeah, the floor is yours.
Yes, thank you very much, Milena. Thank you, Pablo, for this opportunity. Thank you also, Kyriakos, for this excellent presentation. That was very, very helpful. I will share. I'm trying to. Yeah. Do you see the presentation?
Yes.
Yes. So I'm Harris. I'm a senior researcher at Rise Processment. I'm the coordinator of the ALFAFUELS project. And I will try to give in this short time the concept, some first findings, and also the future steps, let's say, for the project. So the project started almost 2 years ago, so we are almost halfway. So here is the concept, let's say. So we start with carbon dioxide as our raw material, and we use cyanobacteria to convert it in isoprene mainly. And this isoprene is then upgraded using a photochemical approach to jet fuels. At the same time, we adopt here a zero waste and circular approach, and we try to valorize different components from the cultivations with cyanobacteria with a cascade approach. And the most important probably stream out of this biorefinery process is that the sugar stream that we produce after the hydrolysis of the cell debris. And with this, we feed microalgae, which are also genetically modified to co-produce starch and hydrogen. And hydrogen is, of course, an important intermediate for the jet fuel production. In the project, of course, there are many other activities. Very important is the different kinds of modeling we have. You will hear a bit more also afterwards. So apart from the metabolic modeling that it's used for cyanobacteria and microalgae to optimize certain threats there, there is also process modeling and kinetic modeling in order to optimize the process, provide data for techno-economic assessments and life cycle assessment, and also to advise bioreactor design at TRL5. This is within the goals of the project, that we build a tailor-made design bioreactor in order to upscale the process. Not only bioreactor, but also a photochemical reactor. So the whole process will be upscaled up to TRL5. So during the first 18 months, so until this summer, let's say, before this autumn, we have working a lot on isoprene production from carbon dioxide, producing different strains, optimizing yields, and so on. We have been working on valorization of cell components and cell debris for production of hydrogen and starch. Also on the photochemical isoprene dimerization to jet fuels. On all these different activities regarding upscaling, and also, of course, all this is in an umbrella, let's say, of sustainability considerations and prerequisites for a sustainable and feasible process. So here you can see the ALFAFUELS product service system. I understand this is a very busy slide, not easy to analyze in this very short time, but it's important to see that we see the whole ALFAFUELS system as one thing, as one system, and we have some inputs there and all the conversions. There was a first system we built in the beginning of the project, and we update this all the time with the new data that are coming in during the experiments and all the interactions we have in the project. And this is, of course, connected and in direct and continuous communication for the assessments, for the techno-economic assessment and the life cycle assessment. Of course, this is the same thing, more or less, but slightly different activities at some points. So here, one important parameter, of course, is cost. So we want to estimate costs as reliably as possible, and that's as in high TRL as possible also, with the data we produce and also with data available from the literature. And then to see the effects and the comparisons with other technologies and current situation for the environmental and other effects on society. So to be more specific, to give you some more insights regarding the findings during the first phase of the project, we have been working a lot on metabolic engineering for cyanobacteria, and we have identified a lot of targets to improve the isoprene production from them. So a lot of strains have been produced up to now, and these have been, most of them have been evaluated at lab scale regarding their growth and isoprene production. And at the same time, this intense work package, these intense activities continue to optimize the cultivation conditions and different parameters that are also important for upscaling, that give us very valuable information about the crucial parameters to upscale this process. Up to now, we have exceeded probably by 2 times the target we had in the beginning of the project regarding the productivity of isoprene. What is important to understand here, probably I didn't mention in the beginning, is that isoprene is a volatile compound. So we can have this is the idea, let's say here, that we can have a continuous recovery of isoprene and a flow to the next process steps without collecting, without, of course, we have to recover it, but we don't have to harvest and dry and do things that normally are done with microalgae. Here is also a quick update regarding the biorefinery approach. So here, as I said, we are trying to valorize different things. On the left, you see some efforts regarding the carbohydrate content, and this is important. As we said, this stream goes to cultivate microalgae for hydrogen and starch production. On the right, you see at the same time from this biorefinery process, we have built some models regarding the lipid extraction. We have also isolated lipids. We have assessed, we have defined the profile of fatty acids to understand the best uses for it. And also we have isolated and quantified also pigments there. And we continue, and it's also ongoing, the protein valorization from the cells. So with the sugars from this process, we feed here the microalgae, and we use Chlamydomonas for that. We have a strategy to produce, to optimize hydrogen and starch production. First, it's the repression of a photoreceptor that has to be done in order to allow the starch accumulation, to optimize that. And then is also another deletion that is done on the cells in order to enhance the hydrogen production. After this, the final step is the introduction, the overexpression of two human glucose transporters, one, but in two places, one in membrane and one in the chloroplast envelope. Here you see some results regarding our upscaling activities and efforts. Also a busy slide. On the left, you see some efforts for upscaling the microalgae production. Here is some parameters are very important, but we have already in the lab also reached quite high growth, at least, and we will continue working with the hydrogen producing strains in order to see also the hydrogen production for these conditions. As you see also in the different photos, we have very different geometries here. This is quite important. You see flat reactors, bubble reactors, stir tank reactors, and we evaluate all this with process modeling, with the kinetic modeling. We evaluate the same parameters in all geometries in order to finalize this and build the pilot scale photobioreactor and the recovery system for the isoprene at the best conditions. So we try this to be, as I said, as a tailor-made system, especially for this application, because the volatile product isoprene is an important parameter here. And then the isoprene is dimerized to the jet fuel molecules. And as I said, here we use photochemistry. We use two different approaches here, two different catalysts at different wavelengths. I'm not a chemist myself, so I will not try to go in much detail about these molecules. But this is also ongoing, and we have also here exceeded our targets at lab scale. And these are the efforts to upscale also the photochemical part. Here you see people working here at our premises at RISE in northern Sweden. So there are many different activities also here involved. With the PIDs and HAZOPs to be done and to understand and design the system and optimize it also, of course, at the pilot stage. So up to now, as summarizing the activities, The biorefinery, the whole approach is almost ready and will be finalized in the next months. As I said, the isoprene production at lab scale has exceeded the target we had set in the proposal. The isoprene dimerization also same exceeded the target, and there is ongoing metabolic, kinetic, and process modelings to feed the upscaling process. For the future, we have already identified, but we will use also industrial flue gases as carbon dioxide streams. We will complete the reactor design and will manufacture 2 reactors, one photochemical, one photobioreactor at pilot scale. We will evaluate the fuel properties, and we will also work on carbon dioxide mapping to understand the landscape there, and we will also dig more in the regulatory aspects. As Kyriakos said, these are very important for the future. And also we have some case studies in Sweden and Italy to see how this technology could be implemented in both countries. Thank you. I hope I did not pass the time by far. Thank you.
Very good. Thank you, Dr. Harris. And now we move on to our third presentation. It will be from microalgae to biofuels, delivered by Dr. Abdullah Turan from SUSTEPS project. So you can go on, Abdullah, please. Thank you.
Okay, thank you, Milena. Let me share my screen. Is it fine? You see my screen?
Perfect.
Okay, thank you again, and thanks for this opportunity. My name is Abdullah Turan. I am a senior researcher at TÜBİTAK Marmara Research Center in Turkey, and I'm the coordinator of SUSTEPS project. And today I'd like to present that EU project of us. First, very quick look at the challenges related with our project. Transport decarbonization, as you know, is a very big issue and requires the development of advanced sustainable fuels. And this is especially an issue for aviation, where there are not many alternatives, sustainable alternatives. And when you get to the biofuel alternatives now, the competition with food, land, and freshwater might limit some biofuel pathways. Circular use of CO2 and waste streams are essential both for the sake of circularity and GHG reductions, but these need to be better exploited. And finally, you'll need technical, economic, and environmental constraints to be fully defined for scaling your process, and for that, assessing sustainability over the full value chain is essential. So in light of this, when we have a look at this objectives and concept of SUSTEPS, we aim to identify systemic barriers and opportunities and foster global cooperation for what? For the development of sustainable algae-based biofuel technology, and we assess the whole value chain here. To enhance the sustainability and cost effectiveness of our process, we incorporate CO2 fixation and wastewater use for the growth of microalgae. And also we try to valorize the side streams of the process as far as possible to enhance circularity. And also we introduce green hydrogen and also in-house produced biohydrogen to feed especially the upgrading stages. Multidisciplinary and international collaboration is an essential part of the concept of SUSTEPS. When we have a look at the fact sheet, this is a TRL for 5-level study, research innovation one, and supported by SINEA, a 4-year project. And we have 11 partners, as you see here, which correspond to a very large geography, as you see here. And this is our process. Our main and actually single biomass source is microalgae. And for that, we have a dedicated study for the growth of microalgae. Here, the motivation is to develop a microalgae growth process, which is able to accept both carbon dioxide at a relatively higher concentration, and also which is able to accept a treated wastewater stream. And regarding the main conversion process, our core process is hydrothermal liquefaction, via which we produce our biocrude oil and subsequently upgrade it to produce our final biofuel fractions. This is the main route, and also, as I said, to enhance the circularity and sustainability of our process, we try to valorize the side streams, namely the aqueous stream and gas streams here. For the aqueous streams, the strategy is to both try to circulate the water as much as possible back to the microalgae growth after a treatment process, and also during this process try to valorize value-added products from these refuse streams. And also for the gas streams, we develop technologies to produce our hydrogen to be fed to upgrading stages. Of course, this won't be enough, so this will be reinforced with a greenhouse stream. Typical electrochemical process. And when we have a look at a summary of the progress, we have our simulation all the way starting from algae to going all the way to the end of the fuel production step. This is an essential part of our process, because we control everything over this simulation, and this simulation is continuously being updated with the arrival of experimental results. It's actually a sort of iterative process. We just go with the assumptions, and then it is updated with the arrival of experimental studies, and this updated simulation results are being fed to the different work packages, technical work packages of the process. Regarding sustainability, our baseline LCA, techno-economic analysis, and social LCA frameworks have already been established. And regarding the algae, we have defined species that are optimized under, as I said before, under flue gas CO2 and pre-treated wastewater medium. So these strains can develop well with a good lipid concentration under the feed of both CO2 and pre-treated wastewater. And for the HTL and the downstream processes, our HTL and upgrading experimental platforms are operational now. We have our initial results. We have both supplied and developed catalysts. We have a catalyst company within our consortium as well, but we also develop our lab synthesized catalyst. So both commercial and new catalysts are within our scope in this project. And we also, as I said, developed an aqueous phase valorization strategy. Via this strategy, we will be able to, the idea is to be able to gain as much as possible the value-added chemicals out of these aqueous refuse discharge streams. Sustainability is at the core, as I noted before, within SUSTEPS, and so far we have developed constructed the pillars of the sustainability assessment procedure. So we have our life cycle assessment, techno-economic assessment, social LCA, and health and safety studies. We have already completed these ones. Regarding international collaboration, not only via our globally distributed consortium, but also through international working groups which we established during the implementation of our project. We are trying to foster international collaboration. These international working groups, we have 5 of them, and these are topic-based, namely sustainability, microalgae cultivation, HTL, upgrading and aqueous phase valorization. Under these working groups, we get together with experts identified before, and with their feedback, we try to tune our process and future studies. We also have clustering efforts, which have already been mentioned by Pablo and Milena, and that has an abstract result, which is SUSTEFUELS. So when we look ahead, in the next phases, we will also update our integrated process with the arrival of new process results. Also, we will have scale relevant validation of key process steps, namely microalgae cultivation and also HTL. We have a new novel HTL process, continuous process. So the optimization, we have our preliminary HTL result, but the optimization will be carried out there. And we will be also going on with the expansion of sustainability studies, not only with the update of new results, but also we will develop case studies, geography-based case studies. As I noted before, we have several partners out of Europe. So those studies will be not only Eurocentric, but we will be able to evaluate different cases like America case, for example. And thank you very much for your time.
Thank you very much, Dr. Abdullah, and thank you all for the presentations. I think it is an insightful presentation on the challenges, market challenges, and innovative biofuels. And now we can move on to the Q&A session. I think Pablo has already some questions from the audience. Yes.
Yes, I've been compiling some of the questions that I read from the chat, and some people ask me. And let me share the screen because I have time to put it in a slide. Can you see it?
Yes.
Okay, so maybe by the time that we answer the others, if there are more questions to Abdullah, you can raise your hand or you can type it in the chat so we can read it, because as the presentation just finished, I didn't have time to include it. But we can start, for example, with the question that I received to Kyriakos. So the first one is, how can Europe adopt a sustainable aviation fuels when it is much more expensive than fossil fuel and competitors like China face lower costs?
There is no easy answer to this question. What was hoped by the industry was that the mandate put by the Commission and, of course, the European Union would, in a way, encourage the industry to invest in this kind of facilities, not only to, let's say, basically to produce in Europe. Now, and the big hope was that the big oil, like Shell in the Netherlands and others, would do that. Because of the geopolitical situation and because of the instability of the legislation we have in Europe, the result was that basically because it says, okay, I don't care so much about SAF, if I may use this expression. If I have to pay penalties, I'll pay the penalties. I prefer to pay penalties than actually building these facilities. Of course, then the hope was that Europe is going to be importing a lot from China and a lot from possibly the US. But again, we see that when the mandate was in a way was planned, China had not yet announced that they were also planning to make a mandate. So that somehow the European Commission went in a way, how can I say, without having a very good understanding of the possibilities of China to go ahead with their own mandate, because China really, they want to really decarbonize their aviation. So there is no clear answer for that. Shall I go to the second question?
Yes. Second question was, how can Europe mandate the uptake of high-cost sustainable aviation fuels without undermining airline competitiveness against lower-cost competitors such as China?
Well, again, the planning was that the mandate would encourage the industry, and by industry I'm talking about the airlines, the airports, even the aviation, the complete aviation sector, as well as the companies developing these fuels, that they will create a kind of an ecosystem, and together they will try to address that. So the idea, of course, it's not to undermine the competitiveness of the airline industry, because this is extremely important. We don't want to do that. And of course, everybody should know that, let's say, the fuels, like kerosene or SAF, is more or less more than 30% of the cost of an airline. So it's a significant amount. So the idea would be that, let's say, if that would be a global movement, that all of us, let's say Europe, the US, China, we're going to go for this sustainable fuel, then everybody would face the same problems. And indeed, we see that China is moving ahead. The only difference is that China is based more or less a lot of UCO. In the US, also they go ahead, but there they are based a lot on the food-based fuel residues, which in Europe our legislation does not allow us to use food-based residues or fuels, and we don't have a lot of UCO. So actually, Europe is in a problem.
Okay, I think that answered clearly the question. The last one you answered already in the chat, but I think it will be nice, since the webinar is being recorded, to put it in, to read it also here. And it is, what are the best channels or the best ways to interact with European Union and inform them on our insights and to help to harmonize and co-develop the future legislation?
There is basically one way: engage to whatever possible extent the European Commission. Engage, of course, your most easy access is SINEA, but SINEA merely, they undertake the management of the calls and the management of the contracts. Critical to discuss with the DG Research, because they are designing the calls. And the DG Research, Mrs. Maria Georgiadou, is the one person responsible. Of course, there's another colleague, Thomas Serkler, but I would try to engage Mrs. Maria Georgiadou, invite her in your meetings, try to find out in DG Energy and DG Move who are the people responsible. I knew them, but I have moved, and I know that many people have moved. Otherwise, I would give you the names. I don't know the names very well. Try to engage them, invite them to come to your meetings. They might decline the first, or the second time they might too. And of course, go to international conferences, like, for example, the EU Biomass and Exhibition Conference that's going to take place in The Hague, because there are going to be many presentations on this topic. So yes, try to engage the Commission. As I said before, they might hear you, they won't listen to you so easily, but if you continue, more or less, they will start opening their ears and their minds to whatever you're doing.
Great, thank you. There was also some announcement and legislation from Turkey in the chat, so I guess this will for sure add some more interesting insights to the discussions. But moving to the project coordinators that we have listening today, I would like to start with Haris. So the first question was, what is the call and projects about competitiveness of the energy sector? This was done during your presentation.
I'm not sure if I understand well this question, to be honest.
Maybe for the proposal writing, I think is
for our proposal. I don't remember. I mean, it was a call on 2023, beginning of 2023, yes, about the fuels of non-biological origin. But here they talk about competitiveness of the energy sector. So probably they refer to a specific call that I'm not aware.
I can look in and paste the link to the chat in just a few moments. So maybe you can answer by that time to the second question, which is, who is the end user in the ALFAFUELS project, and probably explain a little bit the role.
Yes, so we have two end users there. One is Sky Energy, which is one of the leaders, let's say, of the SAF technologies in Europe, and they are very active in different projects and also in high TRL projects. And their role is to also the legislation part and the landscape there, what is happening and what are the important things, but also the evaluation of the jet fuels we produce, so the properties and against the international standards. The second end user is the Eni, is the big petroleum company from Italy. It's an international company, and apart they are doing also a case study in Italy that I mentioned about the feasibility of such a technology for Italy, for their reality, but also they provide side streams from their production sites to be evaluated as carbon dioxide sources for our technology.
Great. And I think I just have one more question for now Abdullah, which is, why is microalgal-based biofuel not yet widely used despite its high potential?
Like every other routes other than HEFA, this technology has its pros and cons. It is promising because you are not limited by sort of, for example, in the HEFA case, waste oil. That is a advantage of algae, but in the meantime, it have other cons, disadvantages, like as Gregorius shared in his presentation, the overall cost is still a bit higher. It is being placed somewhere between HEFA and power to liquid. So, like many other biofuel pathways, it's a challenge. Yeah, that's why.
Great. And I think I have one more question to finish, and it is for Haris and Abdullah. What are the main cost driver of CO2 capture to make projects economically viable? Maybe Haris can start.
Yeah, it's not easy, and of course, cost is of major importance. And to my experience, and especially when we talk about microalgae and cyanobacteria, there are biological factors that are putting more challenges there. One approach we have in ALFAFUELS, at least, is as I said, the volatile fuel precursor, which allows us to omit all the harvesting and downstream processing steps, because these are an important part of the cost for biofuels. So that could be one, and of course the optimization of other factors, working on in low energy processes. It's also very, very important, and this is also we try with the photochemical approach. Also we do some efforts to use physical light. In some locations is possible, in some others is not. So yeah, these are the factors we have, but of course there are plenty, and all of them should be optimized if we want to have a feasible, scalable process. And yeah, for now there are a lot of many challenges remain to be solved. Yeah.
Maybe Abdullah, you want to add something else?
Yeah, for the microalgae cultivation, CO2 fixation is a very good approach where you use CO2 as a carbon source of your microalgae. But there the main problems might be the limitation of the CO2 that can be introduced to the algae medium. Otherwise, some studies report acidification of the medium that might, at the end of the day, dying of the algae species. That is a challenge. Also, the rate, I think, is a challenge. I mean, when you compare the production of CO2, I mean, when you consider the real cases, the production of CO2s, that velocity, and compare to the speed of microalgae, the velocity of the rate of, actually the correct terminology, the rate of microalgae production might not always match. You have to consider your scale accordingly, and I think these might be the challenges related with CO2 and algae production.
Great, thank you so much, both of you. I think we are going to finish just in time. Last but not least, I would like to mention and highlight that the recording will be uploaded in our respective website in the SUSTEPS and ALFAFUELS. We have put the link of both websites in the chat. And so if you probably follow us on LinkedIn and or Twitter, you will find probably when it's available on our social media channels. For me, I would like to thank one more time to Milena for moderating the session, for our fantastic project coordinator, Haris and Abdullah, and of course, Kyriakos for such a great presentation to open the session. So I don't know if you want to add something else.
Thank you.
It was a pleasure being with you.
Thank you, Pablo, Milena.
Great. Then I think we conclude the session. Once more time, so thank you so much, all of you and all the attendees that we had more than 60 persons in live. So that is a very nice number. So thank you so much, and we keep in touch for upcoming webinars. Thank you.
Bye-bye.
Thank you.
Thank you.
Thank you. Bye. Bye.